A strange shape drifts just beneath the surface of the ocean. It's not swimming. It isn't alive in the way most people understand life. It moves only because the water moves it. A translucent purple float catches the sunlight, rising and falling with the swell like a discarded balloon. From a distance, it looks fragile, almost delicate, something you might expect to pop if touched, but this drifting thing is one of the most efficient pain delivery systems ever produced by nature when conditions are right. The wind pushes hundreds of them toward shore, then thousands. Beaches that were calm hours earlier are suddenly empty. Red flags snap in the wind. Lifeguards clear the water as fast as they can. Within a single day, emergency rooms begin reporting burns, welts, nausea, and breathing difficulties. Some victims can barely describe what happened. They never saw what touched them, they only felt it. The Portuguese man-o'-war is not a jellyfish. Even though it looks like one and behaves like one, it is something stranger. A floating colony made of specialized individuals that cannot survive alone. Fused into a single organism that exists for one purpose only, to drift, sting, and feed. Trailing behind that purple float are tentacles that can stretch longer than a blue whale. Thin as fishing line, nearly invisible in water, each one is packed with thousands of microscopic harpoons. These harpoons fire faster than a bullet. They inject venom designed to overwhelm nervous systems instantly. Fish freeze mid-swim. Small prey stops struggling before it even understands what happened. Humans aren't prey, but the venom doesn't care. Even after death, even after washing ashore, the tentacles can still fire. That's why beaches close. That's why warnings go out. That's why most animals in the open ocean give these drifting colonies a wide berth. Sea turtles may mistake them for food and suffer for it. Fish dart away the moment a tentacle brushes the water near them. Even large predators have learned caution. Sharks have been observed, veering off course to avoid them. So when something moves toward a Portuguese man-o'-war instead of away from it, it immediately breaks the rules of the ocean. It doesn't approach from below. It doesn't rush. It drifts calmly, almost lazily, as if unaware of the danger. Its body is small, fragile, barely an inch long. No shell, no armor, no speed, no venom of its own. It looks like it should not exist here. Glaucus atlanticus, often called the blue sea slug, floats upside down at the surface of the water, its back pressed against the tension of the sea itself. Its body fans out into delicate blue appendages that look more like petals than weapons. It doesn't chase prey. It doesn't hunt in the way sharks or whales do. It waits. Like the man-o'-war, it is a drifter. Its entire life depends on currents, wind, and chance encounters. It cannot swim against the ocean. It can only ride it. And somehow, again and again, those drifting paths intersect. When the slug makes contact, nothing dramatic happens. No violent reaction. No visible struggle. The man-o'-war doesn't recoil. It doesn't flee. It doesn't even notice. It can't. The Portuguese man-o'-war has no brain. No centralized nervous system. It cannot feel pain. It cannot recognize threat. It is a biological weapon on autopilot, executing the same behavior endlessly as long as it remains intact. That is exactly what makes it vulnerable. The blue sea slug clamps onto the soft tissue near the base of a tentacle. Its jaws are tiny but precise. Instead of biting into the float or the central body, it targets the most dangerous part first. The tentacles, one by one, segment by segment, each bite removes a section packed with venom. To any other creature, this would be fatal. A single tentacle contains enough stinging cells to cause extreme pain and paralysis. Yet the slug feeds slowly, methodically, as if grazing. It does not trigger the stingers in the usual way. It does not suffer the burns that send humans screaming out of the water dot from the outside. It looks impossible. Inside the slug's body, something remarkable is happening. The stinging cells are passing through its digestive system intact, not firing, not breaking down. Being sorted, some are discarded, others are kept. The most potent ones are transported to the ends of those blue finger-like structures along its body, stored, concentrated, weaponized. What began as the man-o'-war's defense becomes the slug's armor. Over time, the Portuguese man-o'-war grows weaker. Its tentacles shorten, its ability to capture prey disappears, and still it drifts, unaware that it is being dismantled piece by piece by a creature small enough to fit on a fingernail dot. By the time the slug releases its grip, the man-o'-war is no longer a threat to anything, and the slug is now one of the most dangerous animals at the surface of the ocean. Predators that hunt small drifting creatures learn quickly. One bite is enough. The stored stinging cells fire all at once, delivering a dose of venom that can be stronger than what the man-o'-war itself could inflict. Fish spit it out instantly. Birds learn after a single mistake. Anything that tries again doesn't survive the lesson. The blue sea slug does not need to chase, hide, or flee. It floats openly in one of the most exposed environments on Earth and survives anyway. Its colors are not decoration. The bright blues mirror the ocean when seen from above. The silvery underside reflects sunlight when seen from below. From nearly every angle, it disappears into its surroundings. And at the same time, the colors serve as a warning. A message written in biology that says touching this is a bad idea. Sometimes, that warning fails. When these slugs wash up on beaches, people notice them. They look unreal, like something designed rather than evolved. Bright, small, harmless looking, perfect for a photo. Perfect to pick up dot, and that's when the ocean reminds us that beauty and danger often travel together. There have been documented cases of people being stung by blue sea slugs after handling them, even hours after they appeared lifeless on shore. The venom they carry does not disappear when they die. It waits. And when it fires with everything the man-o'-war ever had. The pain is immediate, burning, radiating, accompanied by nausea, dizziness, and, in severe cases, systemic reactions that require medical attention. Many victims never even realize what caused it until much later, all because a creature that looks like a floating jewel learned how to steal a weapon from one of the ocean's most feared. Drifters thought this strategy is rare, but it isn't unique. In other ecosystems, animals have learned similar tricks. Some frogs become poisonous by eating toxic insects. Some snakes develop resistance to venom by preying on animals that should kill them. But the blue sea slug takes it a step further. It doesn't just tolerate the toxin. It upgrades it. And as long as Portuguese man-o'-wars continue to drift across the world's oceans, evolving more efficient venom, the slug will be there with them, adapting in parallel. Two species locked in an evolutionary arms exchange, drifting together wherever the wind decides. But this relationship raises a deeper question. If one fragile organism can hijack the most dangerous weapon of another, what else in the ocean is doing something similar? What strategies are unfolding at scales too small, too quiet, too slow for us to notice? The surface of the sea looks empty, calm, simple, but just beneath it, wars are being fought without movement, without sound, without awareness from either side, and this is only the beginning. The ocean rarely rewards strength alone. Speed helps, size helps, but endurance, patience, and adaptation decide who lasts. The blue sea slug survives not because it is powerful, but because it understands the rules of the surface world better than almost anything else that lives there. Life at the ocean surface is brutal. There's nowhere to hide, no reef to duck behind, no darkness to disappear into. Everything is exposed to birds from above and predators from below. Food is unpredictable. One day there is abundance, the next nothing at all. Most creatures that end up here do so by accident, swept upward by currents they can't fight. The blue sea slug is not here by accident. Its entire body is shaped around the physics of floating. Instead of sinking or rolling, it uses surface tension like a scaffold, clinging upside down beneath the water's skin. This position keeps it exactly where its prey lives. Portuguese man-o'-wars drift at the surface because their gas-filled sail demands it. The slug evolved to meet them there. When currents concentrate man-o'-wars into massive blooms, the slugs follow the same invisible highways. Entire populations rise and fall together, their fates intertwined by wind direction and seasonal storms. When one appears, the other is often close behind. To the man-o'-war, this means danger it cannot perceive. Every part of the Portuguese man-o'-war is specialized. Some individuals within the colony are dedicated to capturing prey. Others digest. Others reproduce. None of them are built to defend against something that eats them slowly from the edges inward. Evolution shaped it to kill fast-moving fish and deter large attackers, not to notice the small grazer dismantling its weapons. That blind spot is everything. As the slug feeds, it does not rush. Too much venom at once would overwhelm even its defenses. Instead, it carefully meters its intake, allowing its body to process and sort the stinging cells without triggering them. Scientists believe the slug's tissues chemically mimic the man-o'-war's own surface, preventing the harpoons from firing. It is biological deception at the microscopic level. Even then, it's not perfect. Some stinging cells do discharge. The slug absorbs damage. Its life is short. Most individuals live less than a year. But in that time, they are nearly untouchable, and that changes the balance of the surface ecosystem. Man-o'-wars are not top predators in the traditional sense, but they exert control simply by being dangerous. Many animals avoid areas where they are concentrated. Fish distributions shift. Feeding patterns change. When blue sea slugs reduce their numbers, those effects ripple outward. This isn't domination. It's quiet regulation. The slug doesn't wipe out the man-o'-war. It doesn't need to. It only needs to survive alongside it, feeding when opportunity allows, drifting away when it doesn't. Evolution favors the relationship because neither species gains enough advantage to eliminate the other. Instead, they coexist in a delicate, drifting balance. Humans notice this balance only when it breaks. When storms drive both species toward shore, beaches become flashpoints. People see the purple floats first. They don't see the invisible web of tentacles beneath them. They almost never notice the slugs at all. Scattered among seaweed and foam like dropped fragments of sky, that's when curiosity becomes dangerous. Unlike the man-o'-war, the slug does not look threatening. It doesn't look painful. It looks artificial, something fragile, something safe to touch. And unlike many venomous animals, it doesn't hiss, bite, or warn in any obvious way. Its defense activates only when it's too late. When human skin presses against it, the stored stinging cells fire instantly. The venom does not distinguish between predator and accident. The pain is sharp and intense, often worse than a man-o'-war sting because of how concentrated the venom has become. In some cases, symptoms last for days. This is why marine biologists emphasize a simple rule: never touch anything in the ocean you cannot identify with certainty, especially not the beautiful things. Ironically, the blue sea slug's greatest defense against predators has made it more dangerous to humans than the creature it feeds on. Yet despite its potency, It remains incredibly vulnerable to changes in the environment because it drifts. It cannot escape warming waters, pollution, or plastic debris. Microplastics accumulate at the surface where slugs feed and float. Oil slicks suffocate surface tension, destroying the very platform that keeps them alive. Climate-driven changes in wind patterns alter where man-o-wars appear, and the slugs must follow or starve. Their survival is tied not just to their prey, but to the stability of the ocean's surface itself. This makes the blue sea slug an unexpected indicator species. When they appear in large numbers, it often signals shifts in currents, temperature, or storm frequency. When they disappear, it can indicate disruptions that ripple far beyond a single species. In that way, this tiny creature tells a much larger story. It reminds us that the ocean is not divided into neat layers of importance. The surface is not just a boundary between water and air. It is a living battlefield shaped by physics, chemistry, and chance. The smallest organisms can exert outsized influence. The most dangerous weapons can be stolen, and survival often belongs not to the strongest, but to the most adaptable. Somewhere right now, far from shore, a Portuguese man-o-war drifts beneath the sun. Its tentacles spread wide, its venom ready. Nearby, unseen, a blue sea slug floats upside down, waiting for contact that will decide which of them feeds and which of them fades. And beyond that interaction lies a bigger question. If a creature this small can hijack venom, store it, refine it, and deploy it better than its original owner, what other biological thefts are happening across the ocean? How many survival strategies remain undocumented simply because they don't announce themselves with speed or violence? The deep sea hides its mysteries in darkness. The surface hides them in plain sight, and the closer we look, the more it becomes clear that evolution is not just about creating new weapons. Sometimes it's about knowing exactly when to take someone else's. The relationship between the blue sea slug and the Portuguese man-o-war is not frozen in time. It is still unfolding. Every generation is a test. Every current shift is a pressure. Every mutation that improves venom potency or resistance is either rewarded or erased. Evolution does not choose sides. It only keeps what works. The man-o-war has one of the most efficient venom delivery systems in the ocean. Its stinging cells evolved to fire with precision and speed, injecting toxins that disrupt nerve signals and overwhelm muscle control. For millions of years, that was enough. Anything that touched it suffered. Anything that learned avoided it, then something learned how to touch it safely. The blue sea slug did not become immune in a single leap. It likely began with partial resistance. Individuals that could tolerate brief contact fed a little longer. Those that could transport stinging cells without triggering them gained an advantage. Over time, natural selection refined the process until the slug was no longer just resistant, but capable of repurposing the weapon entirely. This is not parasitism. It is exploitation at a cellular level. The slug does not neutralize the venom. It preserves it. It does not break the harpoons. It reloads them. In doing so, it flips the rules of predator and prey. The man-o-war becomes both food and armory. What makes this strategy even more remarkable is how precise it is. The slug does not store every stinging cell it consumes. It selectively retains the most potent ones. We still don't fully understand how it recognizes which cells are strongest, or how it prevents them from firing while in storage. Even now, scientists debate the exact mechanisms involved. That uncertainty is part of what makes this animal so important. Biology tends to reuse ideas. When something works, it appears again in different forms. Venom theft may be rare, but it reveals a principle. Defenses can be hijacked, refined, and turned outward. This idea has implications far beyond one slug and one drifting colony. Studying how Glaucus atlanticus handles venom could influence how we design drug delivery systems, how we store unstable compounds, and how we protect tissues from chemical damage. Nature often solves problems that technology struggles with, quietly and efficiently. But there is another side to this story, one that carries a warning. The same forces that shaped this evolutionary arms exchange are now being altered at unprecedented speed. Climate change is warming surface waters. Storm systems are growing stronger and less predictable. Human activity is changing current patterns that have existed for thousands of years. When those currents shift, so do the drifters. In recent years, man-o-war strandings have occurred in regions where they were once rare. Blue sea slugs have followed. Beaches unaccustomed to these animals are caught off guard. People don't recognize the danger. Warnings come too late. Encounters increase. What was once a distant ocean interaction becomes a human problem, and humans, unlike most predators, do not learn through instinct. We learn through experience, sometimes painfully. A creature that evolved to deter fish and birds now has to contend with curiosity, tourism, and misinformation. This makes education as important as biology. The blue sea slug is not aggressive. It does not seek out humans. It does not attack. Every sting recorded is the result of handling or accidental contact. Yet the consequences can be severe. Understanding this changes how we share space with the ocean. Admiration does not require touch. Observation does not require interference. As research continues, scientists are beginning to map these surface ecosystems with greater detail. Satellites track blooms. Models predict drift paths. Beach closures are planned earlier. Awareness grows. Slowly, the gap between human behavior and ocean reality narrows. Still, much remains unseen. Out there, beyond shipping lanes and coastlines, the surface of the sea continues its silent exchanges. Drifters meet. Weapons change hands. Survival is negotiated molecule by molecule. No spectacle. No sound. Just outcomes. The Portuguese man-o-war will continue to drift, trailing its venomous reach across warm waters. The blue sea slug will continue to float upside down, waiting patiently, carrying stolen fire along its back. Neither knows the other by name. Neither understands the significance of their interaction, but together, they demonstrate something fundamental about life on Earth. Power is not always about force. Sometimes it's about understanding. Sometimes it's about patience. Sometimes it's about knowing exactly how to turn an enemy's strength into your own. The ocean is full of monsters, but it is also full of thieves, engineers, and quiet strategists. Some of the most effective among them are the ones we overlook because they are small, beautiful and silent, and somewhere right now, beneath a calm horizon that looks empty to the human eye, a tiny blue shape drifts toward a purple shadow, ready to steal another weapon and remind the ocean who truly survives.